in the Python series. So we are going to study today something more. Last week we studied about Python and how to declare the sandbox variables, how to deploy on the sandbox. Then we created a wallet for the test network environment, and we deployed over there also. So today we will extend that a bit, and today we will create a simple fungible token which we will deploy on the test network, and then we will try to see if we can have that opt-in transaction also. So by default in Algorand, there is a security mechanism that you cannot even by mistake send your tokens to someone else. For that to happen, you have to have an opt-in transaction from the other wallet to which you are sending the tokens. And with that wallet hasn't opted in, you will not be able to send your tokens to them. So it is a safety guard which is implemented by Algorand, right? So let us first start first thing, creating the token. Then we will see that if I directly can transfer the token to some other wallet or not without opt-in. Then we will have opt-in transactions also, right? So give me a moment. I'll share my screen. Let me know once my screen is visible.
It's visible, Sunil, but I just see Zoom right now. Can you just play? Yeah, now it is.
Yeah. So over here, again, I'll just go to the part where I normally store my code. Don't worry, it's not a command, it's a drive name. So over here, I'll have, let's say, because we have AlgoGyaan sessions, and so I'll just create a directory. April. I'll cd to this directory. Or, yeah, that's fine. Now I'll have algo init over here. So I'll have algo kit init, not algo init. Okay, we have the first thing. Last time we did this one. So smart contract. Then we'll select Python. Then name of the directory. So the same directory, I guess enter will should work. Okay, so enter, we have to enter a value. I can say hello world. Okay, then it is starting to create the templates and all. So name of the smart contract app, that's fine. Hello world, I'm okay with that. We can use a starter template. So we are going to use the same starter template. With Python, yes. And then it is asking us whether we want to install all the dependencies for the code. Then we should just say yes. And it will install everything. We have to wait while it installs everything, and then it will just get back to, it will open the Visual Studio Code so that we can start from coding from there. Okay, so this is what we got. If we open the smart contract templates on the left hand side, we see the hello world, and over there we see our contract, which we deployed the last time, right? Now the point is we have this deploy config py file also, where we can write the entire function which is written over here, right? So we have bifurcated two files. One is your contract and the other is the deployment part, right? Since we are not writing a contract, because there is a conception, or there is misconception rather, that even if you want to just create an asset, you have to deploy a contract. No, you can create an asset by simply having a Python function. So today we will just extend the function step by step, right? And then we will create our first token, right? So the first step in creating any token, the first step is you have to have a test network wallet, because we are creating on the, you can say testnet, right? That is your first testnet wallet with minimum, you can say one algo. It will not require that much, but still, let's say hypothetically one algo. That is for test network environment. Testnet wallet with one algo. That is first requirement. Then what is the second requirement? You need to connect to the test network RPC URL. So testnet RPC URL or RPC client, you can say. Now, what is an RPC? RPC is basically remote procedure call, right? Then, what is the third thing we have? In this case, nothing. We need two things only, wallet and RPC. Because third thing, you may have a smart contract, but currently we are not deploying any smart contract. So we'll not need the smart contract. But what these two things are mandatory for us to implement anything, right? Now over here, there are certain things which are already created for you, which I don't want. Why? Because I need to have a test network wallet. So what I can do, we know that what we can do is, let's say account, then equals to this one. You can create an account, or what you can do from mnemonic we can do, right? We know that it is from mnemonic. It is also possible to get an account. And over here, you have to pass the mnemonic, right? So this way you can create the account. Now let me just quickly go to my code and get my this one. So this is the account we have created, right? AlgoKit account, AlgoKit underscore utils dot get account from mnemonic, and whatever the mnemonic we pass, it will create the account over here. If you want, we can see that account dot address. That is basically your wallet address. If you want to see which is the wallet address. I've already connected this wallet address to app.devflow. So you can see that P5CS, this is the one wallet which we have just connected to the network or connected to the code, right? So first step is taken. We have account. We have this particular account which is created by me. And fortunately, it has the enough fund. So if you can click over here and select View in Explorer, you will see that the balance in this particular account is 163 algo. So that is enough for us to manipulate or to create the asset and all. You can see that I am holding these many assets and I have created these many assets, right? So for me to keep all these assets in my account, the minimum balance I require is this much, right? So if I go over here in the assets bar or in the asset manager, I'll be able to see all the assets created by me, right? So I was testing before this session. Now all these you can say tokens or fungible tokens are created by me, right? So now let us come back to the second step. So second step now we have the test RPC URL. We'll need the test RPC URL. So from where we are supposed to pass, we are supposed to change this parameter. Currently it is pointing towards what? Currently it is pointing towards sandbox, right? Which I don't want because I want a test network URL for me. So what I'll do is I'll go D, this one. I need a different information for this particular piece of code. So what I'll do, I'll just get quickly that code from the other part, and I will need this information, right? So the same thing which you saw. Now, if you want to deploy this one over some other network or some main network, that also you can do, right? This is just for a string for the main network. So I'll remove that string. We don't need that. What do we need is this one. So this is good, right? So this is basically, you can say that it requires two items. One is your basically RPC URL and the particular string for decryption encryption purposes. So this is basically the other piece. Now, what happened? We got the wallet, we got the RPC URL. So now we are able to connect. But third thing is missing over here is we need, because we don't need a smart contract, but we will need a transaction, right? Now, transaction is a two-step process. So what is the first step? The first step is create an object of the transaction, right? That is your first step, creating an object of the transaction. And the second step is sign the transaction, right? Using what? Using whatever wallet you have created. Let's say test network wallet. And the third step is submit the transaction. Submit to where? Submit to the network or submit to the test RPC URL. So first step, create an object of the transaction because that will be an unsigned transaction. Then sign the transaction using your test network wallet. And third one is submitting the transaction, right? So now as a third step over here, this is done. This is taken care of. Now I'll go these and over here, app client we are passing. But then here, I need this particular wallet address. So I'll just change the name from deployer to my account. So now the app client object will take Algorand client, this one, and creator as my wallet address and not the sandbox wallet address. So now this will not talk to the local environment, right? This will directly talk to our test network environment, right? So as a third step, now third point, our first step in the third point is we have to create the transaction object, right? Now this transaction object is basically a transaction class from where we can identify that which kind of transaction we are going to have, right? So give me a moment. I'll copy the code from there. Yes, we need this one, right? So we'll create a transaction object, which is basically from Algorand SDK, which is a Python SDK. From there, it's a transaction class, and then we can have asset config transaction. Now you can see that it is already giving me an error because I have not imported the Algorand SDK. So I just need to import that, and we are good to go. Once we do that, we are able to see everything is in green now. And the moment you hover over this asset config transaction, you can see that this many information or this much information we are required, right? So over here, all the kind of whatever is required, all this information is given to you. And you can see that over here, any. So if you don't give anything like this over here, it will be okay. Certain piece of information you may or you may not give. In Algorand, the network understands or bifurcates the kind of tokens. Let's say I want to create an NFT versus I want to create a fungible token. So if you pass the URL, it becomes an NFT. If you don't pass an URL, it becomes a regular fungible token, right? So just remember that. Now, since this is the one which we are going to have, and what I'm going to do is I'm step by step, I'll explain you what are the other parameters which are required, right? So we can have this copy from here to here. So the first thing is it is telling me that who is the sender of the transaction. So I need to pass what I need to pass. I need to pass the account or the wallet address. Now you see that over here, this is not a wallet. This is an account class, which has both the things, wallet as well as, I mean to say wallet address as well as the private key. So I cannot just pass this account object as it is for here. Why? Because the sender expects a string variable, which is basically an address. So you can see now address is a string variable, right? That is your first argument, which is mandatory. Then this is also mandatory, right? Which is sp equals to algorand underscore client dot suggested underscore params. Now this actually is trying to fetch some network level parameters we need to pass. If you forget to pass this argument, you will never be able to have any sort of transaction submission to the network. This is absolutely mandatory. Why? Because this will give the fees and what is the last round of block and the other various network level parameters which we are supposed to fetch and then pass. So from here, from this particular function, we are fetching and we are passing to SP, right? Then this is basically how much fungible or how many fungible tokens you want to create. Let's say 5,000. Then if you want to create a fractional token, you can. If you provide the decimals over here, it will be a fractional token. That means you can buy like 1.35 or something. But we are not creating a fraction, so that is fine. Then default frozen. No, this asset is not frozen. We are just trying to create for the first time, right? So over here also, I'm going to have this token name, let's say Gyaan token or Gyaan coin, let's say, and I'll have GC1, right? Or GCN, right? This is the token name. So asset name and unit name, basically this is, you can say, a symbol and this is your name. Then over here, you can have a description also if we want. If you have metadata hash, because we don't have an NFT right now, so we don't need this. But there are two other parameters, manager and clawback. Now, let me give you one more thing about Algorand is, Algorand also plays certain, you can say, safeguards in order to protect your transactions. So over here, if you have defined the manager's address also while creating your asset, somehow, let's say hypothetically, though the address which or the wallet address which you used to create the asset gets compromised. And if you have a manager account, which is a different wallet address, you can directly use that manager account, overriding everything. So you will not lose control over your wallet or your money, right? That is the main idea of having this one. And clawback. So tomorrow, if you decide, let's say you have transferred some tokens to some people and all, but tomorrow you decide, okay, that particular couple of guys are maliciously playing a role and they are like trying to hurt the network, or they are trying to hurt your idea and all, you can take those tokens back. So clawback is used for that purpose. Since we don't have the account one, it is giving me an error. So I'm just removing that two parts from here. And this is the last thing is basically strict underscore empty underscore address underscore check. Now, if you guys are aware, any kind of wallet address, basically, let's say this is the wallet address. And if you select to view this wallet address, what will happen? You will be able to see this address. But if I convert into a normal hexadecimal value, then I can pass a zero address also, like 0000000, having this length, right? And if you do that, that particular, you can say, asset will be useless because nobody has the private key for that sort of address. And that's why this is a, you can say, safety guard against that. So what I meant is something like this. That is called a zero address or empty address or something like that, right? I'm not never tried. You can try whether it fails or whether it succeeds. You can try, right? Then your object for creating an unsigned transaction is done. But I want to check that how many other kinds of transactions I can do. So what I can do is I can see Algo SDK. Okay, I have done that transaction. Then I can put a dot and see what sort of transactions I can do, right? And over here, let's say asset configuration. That is, I did that. But since I have to create an object, so I'll say, let's say we are doing unsigned underscore txn1, let's say, hypothetically, so that we don't get an error. From here, I can do Algo SDK, okay, dot, we have transaction, right? And then we can see create. So over here, what is the first thing we have done? Asset config. That is, we are creating the asset create. Asset create also is a transaction. Asset destroy is one more transaction. Asset freeze, asset opt-in, asset transfer, asset update. All these are asset related transactions which you can create while using your entire, you can say, transaction object, right? So I'll remove this code for now. And we know that the next step is we have to sign the transaction, right? So as a next step, I'll pull one of my codes over there from the other part. And that is we are signing the transaction. Now for signing the transaction, what we are doing? Very simple. Unsigned transaction, we are calling the sign function, and over there, what account we have created, its private key we are using to sign the transaction. And now your unsigned transaction become the signed transaction altogether. So now what will happen? Your transaction automatically signed by the wallet by this call whenever this particular piece of line or piece of code gets executed. Clear? So first of all, again, guys, repeating because this is an interesting procedure and everybody needs to understand how this works. So first of all, we have created the wallet from the mnemonic, from the test network. Okay. I already had some tokens in that. So for me, it was not mandatory to fill that token from Algorand test bank. Then I have passed the RPC URL that I've already done. And the third one is we are at the third step, or rather you can say first step of the third step. And as a first step, we created the unsigned transaction object with this many parameters. Now we have created the signed transaction using the wallet which we have created, and we signed with the private key. Now, third step, we know that it is a submission of the transaction, right? So let me pull the code from here. Now over here, I want to see what is the fees which I'm going to pay, right? For submitting the transaction on my network. So I'm just printing this statement, unsigned underscore txn fee. But here, what I need to do is I'll just replace, instead of print, I'll use logger.info. So it will be a proper printing statement for it. Now over here, I'm submitting the transaction. Now we know that submitting transaction will require an RPC URL. So you can see that I have created an object AlgoD client already over here, right? This is that object AlgoD client and from here, right? So I am submitting to that AlgoD client via calling a function called send transaction. Now this send transaction takes an argument, and that argument basically is the signed transaction. So this is the signed transaction I'm passing over here as an object, and I'm calling the function called send underscore transaction, right? So now what will it return? If you hover over here, you will see that it returns a TX ID, which is basically a transaction ID in the string format. You can see it is mentioning str transaction ID, right? So what is it returning? Transaction ID. Now, why this is mandatory for us? So that we know exactly that our transaction passed or not, and what is the transaction. So we can verify over the blockchain, right? So this is just, I'm having a printing statement, logger info. Over there, F basically, whenever I have these curly braces, I can replace with the information. So over here, I put everything inside double quotes. But when this happens, this particular piece of code, you can say, starts to execute, over there, it will replace with this with the variable. And what is that variable? This one, TXID. So for now, what will happen over here? I will pass the transaction ID. I will submit over there whatever transaction ID I got, and I'll pass that into logger.info, and it will print, right? But then again, I mean, this is results of one more statement. And over here, I'm doing this one, waiting for confirmation. So now I'll ask my dear friend Mudassir a question. Mudassir, what is this transaction? We have already submitted. So why do we need this one? Mudassir, are you there? Is trying to speak, I guess. Mudassir, you are not audible if you are speaking.
Hello, I'm audible now?
Yeah, you are audible, but very low sound.
Yes, hello. Now?
Yes, now you are audible. So we have submitted, we have like signed the transaction, we have sent the transaction. Why do we need this transaction?
So because so wait for it will we have to wait for particular time interval to get the confirmation
Yes, but
received.
that is what I'm asking. Why do we need to wait? Okay, guys, now let me answer. So every transaction in normal Web2 world, whenever you create a transaction and hits the database and we are done, right? There is no after process or there is no waiting period over there, right? But over here in blockchain, transaction is once a transaction is sent to the network, it doesn't mean that it is written into a block, right? There is a misconception in the market that when we write a transaction, it is already written in the block, but that is not the case. So what happens over here is whenever you submit a transaction, millions of transactions are being submitted across the globe. So all those transactions will stay within a thing called mempool. So this mempool will have all the transactions over there compiled, or you can say waiting for any miner to be picked up and to be put inside the block. And that basically, once all those transactions are put inside the block, the algorithm automatically generates a Merkle hash or Merkle root hash, which becomes the, you can say, sort of a primary key for the block, and then the block gets added, right? So once the block gets added to the blockchain, then your transactions are properly added to the blockchain. Even if your transaction is confirmed, but till the time it is not added to the blockchain, it will not become a part of the blockchain network. And sometimes, not in Algorand, but other platforms, it may happen that sometimes the transactions stay in mempool and never get recorded on the blockchain. So you have to do the transaction again. That also happened in the past. But here in Algorand, what happened is the block finality time is almost immediate. That is 2.9 seconds. So whenever the newer transactions are there, it will always be picked up immediately and then will be put into a block by some miner. Now, why immediately? because the transaction fee is same. While there is no, like, if you're in urgency and if you want to expedite or picking up your transaction, I mean, the other networks support the higher gas fees. Over here, there is no concept of higher gas fees. The gas fees is same for every kind of transaction, right? A true sense of decentralization, where even if you are, I mean, there is no point of paying additional fees or something. It will pay exactly the amount which is required, which is the lowest one, which is the same one for everyone, every transaction, right? So that is the beauty of it. Because of that, we will wait. So Algorand SDK transaction, we will wait. Why? To get the results back. And the results will tell us that exactly after which round, that is called confirmation round. Confirmation can happen among the miners, and they will agree that, okay, they will reach to a consensus that this is a valid transaction, and then the transaction gets the confirmation part. So once we get the results object over here by waiting from this particular transaction, you can see that the confirmation and all, it's everybody. So over here, it is accepting 3 arguments. One, Algorand client, of course, because we are publishing over there. Then the transaction ID itself, right? That's what we received from the first transaction. And then how many rounds do we need to wait? So, I mean, for default, you can say 4 rounds so that you don't need to wait much and all. Then on the results part, we will get the results from which round actually gave us that consensus confirmation among the miners. And that's where that it is confirmed now your transaction is passed and written into a block. And for us, an asset is created. And then we can see that from the results, we can pass in the asset index. We can see the created asset, and I'm printing the asset over here, right? So this is the final step when you submit the transaction. Right? And this is just what asset we have created. I just wanted to have that asset. So I wrote this transaction, right? This has nothing to do with blockchain. It is just, you can say, pulling the data from the results object, right? So as I mentioned, this is a 3-step process. And now we are at the end of third step of the third step, right? So ultimately what happened over here, we have created an account and deployed to a network, and we created a token. Right? Now, hopefully everything should work. So I'll just keep my fingers crossed. I'll save the file and let me deploy. So deploying will not require much things. I'll just have start debugging by selecting the file on the left-hand side, and then we have to wait. If everything goes right, it should deploy the token on the network. Fortunately, no error till now. Yeah. So I'll take my statement back. Now, algo client config object has no attribute suggested parameters. Why? Because we have already done the algo client. Over here, we replaced that. It should talk to this one. So it should work. Why it is giving an error over here? Okay, let me just stop that. Just give me a moment, guys. It should work because it worked over here. I managed to create everything. And this is the same thing we have done over there also. Okay, I may have done something wrong. No, over here it is all the same thing. Get Algorand client. Ah, okay. This is what I missed, right? So I need to write this one and not the other one. This is basically the misuse of AI, guys. It should have written this one, but by default it selected something else, and it gave me an impression that my code was right. So now let me just again start debugging or deploying. So it loaded the environment. It is trying to deploy the code now, deploy whatever we have written. So first of all, it will create an asset and then we'll deploy the hello world. This time it should work. Yeah, again, same problem. AlgoGyaan takes 2 arguments. Let me stop it. What 2 arguments? We have passed only 2 arguments. Let me just copy this as it is without any change. Let's see whether we have made any mistake or not. Okay, let us run this third time. Third time is the charm. It should work now. Yes, it worked. Successfully sent the transaction with the ID and the confirmation is there. And we have successfully created the asset also. 640602685. Hello world is also deployed. You can see my wallet address is printed in this line. And then regular hello world is called. But most importantly, the asset is created for us, right? So over here, we can see that 640602685. This is the asset ID created for me, right? So if I go over here and check the asset manager, I'll be able to see the data over here, which was Gyan coin, the token we have just created. Now it is displayed with 500 GCM. Total supply is this much. The ID 640602685, which we have just seen over here. The ID created by us or created by the code, right? And you can see that 1000, that means your 1000 micro algo, that is basically 0.001 algo as a gas fees. If you want to take a look, you can see over here the transactions which we have done. So I'll go into View Explorer part and you will be able to see the fees. The last transaction is 0.001 and the same application ID is mentioned over here, right? So basically what happened, I was able to create the token successfully. Now the point is the second one, basically, just a second guys. So basically an asset is created. Now I told you earlier that there is a safeguard from Algorand that accidentally also you cannot send your assets to someone else, right? So let us take a look how that system works. So since I can see the asset over here, the Gyan coin, I want to send this asset to a second wallet of mine, right? That second wallet is connected over here. This is my second wallet, right? You can see this particular wallet does not have any kind of asset over here, right? Now, what I need is, I need this asset address copy. The wallet address copy. So I'll copy the wallet address. I'll go to my first token where I've created Gyan coin and I want to send this Gyan coin to my other wallet address. So I'll click over here and it gives me an option of sending assets. Okay, I'll send the asset. I'll paste the address over here and I'll see, because since I have 5,000 assets, I'm okay to send 5. Now, as soon as I do that, since this particular wallet is connected through my mobile, I have to sign a transaction on my mobile. So let me open that Pera wallet app in my phone. Give me a moment, guys. Yeah. And I'll click on send button. Now, sometimes you forget that you are connected to a mobile network and you forget to check your phone. And this keeps on moving like this, right? Because now it is waiting for the confirmation from wallet. So I'll press the confirm button on my wallet. So you can see that error immediately is there, right? And what was the error? Okay, let me try again so that you can see what was the error. So it will again ask me, and as soon as I press, the error says something like this, right? Must obtain. That means this particular asset is not opted by the second wallet address. And since it is not opted, that particular wallet will not be able to access my asset, right? So there are two ways to do. So what can I do? Since I know the ID of this asset, I'll copy this ID from here. I'll go to my second wallet address. I'll go to opted. Then I'll click on this button, opt-in. I'll paste from asset ID, I'll select and I'll paste the value over here. And you can see that Gyaan coin is found. Then I'll select the Gyaan coin. Okay, I need to sign the transaction again. I told and I also forgot to sign the transaction on my phone. Yes, opt-in, confirm. So waiting for confirmation because it is confirmed from my side. And it is done. So what happened over here? We can see that in the opted part, now I can see the Gyaan coin. Now, this particular second wallet is ready to receive Gyaan coin from my wallet. So I'll go to my first wallet. I'll do the same procedure again, right? I'll do the send asset. I'll need an address. So I'll go back to my main wallet. I'll copy the address. I'll come back over here and I paste. Now I'll transfer again 500 GCN. Send. It will pop up on my phone. Yes, confirm. Waiting for confirmation. And we can see that the transaction is successful. So if I go to my secondary wallet and if I refresh the page, I'll be able to see 500. Yes, see. So that means without this opt-in, you will not be able to get the tokens in your wallet. But this was done using this particular piece of, you can say, this particular website. How to do this using code, right? So just give me a moment, guys. We have to create this particular process. Now repeat till the signing of transactions from here. So what I'll do is I can say that now we are doing an opt-in transaction, right? So I'll go back quickly to my main my code and I'll start copying from the same. So again, I will have the transaction, the unsigned object or unsigned transaction. This time what I have done, instead of asset config, I have used asset opt-in transaction. That means now my particular, you can say a wallet is supposed to be ready to accept or to create an asset opt-in transaction, right? But we forgot the most important part is having the second wallet address, right? So what I'll do is I will quickly create one more account 1 equals to same from mnemonic. I'll have double quotes over here and I've already used that mnemonic for my other code. So I'll quickly get the mnemonic from there. Yeah, this is the mnemonic for my second account. And now our second address is also ready, right? Don't worry whether you see that, okay, length is different because certain spellings are longer, certain spellings are smaller. That's why that is the problem. Otherwise, the 25 words are fixed, right? For the mnemonic. Now we know for the second asset opt-in transaction, what do we need? Account 1. Why? Because that is the account which is going to perform the opt-in transaction, right? Then we have SP and then we have index. SP we already discussed. Now, what is an index? So index is basically the asset which you just created. I want to opt in for the same asset. So I opted in for the same asset, right? So now my account 1 will be automatically ready once the asset is created because I will pass that asset ID from this particular variable to here. So now my object is ready. Now what is the second thing? Second is my sign transaction, right? And sign transaction basically is what? How do we sign? Unsigned transaction dot sign, right? And in the sign, we will need the private key. So account one dot private key, and we are good to go. So my account is now, what is the second step I have to take? The second step I have to take is sign the transaction. The second step is also done. The third step is submit the transaction, right? So let us see the third step code. Yes, so unsigned transaction is done, signed transaction is also done, and we need just this much of information. I'll copy this. I'll quickly go back to my previous code and I'll paste the code over here. We see the same parameter. I'm trying to print the transaction fee. Instead of print, I'll use logger info. So logger.info. Then we have same transaction ID, transaction, whatever signed transaction I'm you can say submitting to the network. Over here, the same piece of information. But since we are not creating any asset, we are not going to have that asset confirmation or asset ID printed over here. But automatically, my account one will also have an opt-in transaction as soon as the asset is created, right? So I'll just quickly save the code. We have done everything. Now what we need, what is left for us? Nothing. We can just quickly deploy. So I'll save the file. I'll quickly go to run. Let me check whether this file is selected. Yes, run and start debugging. So it will first create the token or the asset with the same name, but we forgot to change the name. That's okay. We can still, because the ID will be different, so it will be given to us that the ID is different. So 1000 transaction ID is there. We'll soon see the ID of the asset. The asset ID is now 640603398. The fees and everything is printed. Result confirmation, hello world, and everything is done. Now we will say the same information happened in the last time also, right? So Mudassir will say, sir, this is the same information. So what is different? So now let us first of all see that, okay, 640603398 is the asset ID created or not. So I'll just refresh the page. Since this is the ID which is created, 3398, the asset is created. But the difference between this asset and this asset is this particular asset is now already ready to accept or to send the transaction to my second wallet address. Why? Because we performed the opt-in transaction. So if I copy over here the address, and if I go back to my wallet P5CS, and if I send over here, send assets, the wallet, and 1000, let's say, send. It will have a confirmation on my wallet. So give me a moment. Let me sign the transaction. So if you remember last time it immediately raised an error. Today, this time, it did not raise an error, right? We did not perform an opt-in transaction the way we did for the previous asset. Here, we did not do that. And if you see the transaction, you will be able to see that transfer transaction happened. This is the block which registered the transaction. Sender is my wallet address. Receiver is the other wallet address. And the asset transferred was 640603398. That the amount was 1000 GCN. If you go back to my second wallet, and because since we are on the opted screen, one more Gyaan coin with the 1000 tokens have to be there. And it is there. Here. ID 3398. The previous one was 2685. And now we have 1000 over here and 500 over here. Right? So this is the way you can create an asset, very simple, and then you can perform an opt-in transaction also. Opt-in transactions are mandatory in order to receive any kind of tokens created by Algorand. It can be fungible. It can be NFT like ERC3, ERC63, ERC69, any kind of transaction, right? It is mandatory for you to have that opt-in transaction, right? So that basically marks the end of our session over in terms of my programming, that what needs to be done or what needs to be showcased to you guys. So now, since we have 5-7 minutes left, so we are open for any questions. So anything, anybody. This entire code is, you can see that written in Python. No beaker, there is no other object over here. It is pure and simple Python. You can see that Algo SDK, and from Algo SDK, we are just using this one, right? Nothing more, no other parameters, no nothing. It's just that we are using all these things inbuilt. And that's what we are trying to extend the code. So it is all basically very, very simple, right?
I
Okay.
have one question.
Yeah, go ahead.
So it is a very basic. Actually, I am new to Algorand.
Yeah,
So
go ahead, no problem.
my question is, what is the difference between NFT and asset?
So asset, when you don't, technically no difference. But when you provide a URL over here, there is one, if you see asset config transaction, you will see that URL is a parameter you are supposed to pass. So if you pass that URL, and one more parameter you need to pass is this one, metadata hash. So if you pass these two items over there, it becomes an NFT. If you don't pass these two items, it becomes a fungible token or it becomes an asset.
Okay.
Right? So thanks, Jai.
Yeah.
Okay, anyone else? Mr. Mudassir, any questions?
No, sir. Thank you.
Okay. Anyone else? Any other question? Don't think whether there is small, basic, advanced, anything. You can just please ask me those questions, because we are here to help you guys in order to take the first step towards Algorand, right? Okay, Mudassir, you want to share about Discord or anything else, YouTube channel and all? So please go ahead.
Yeah, sure.
So let us give a moment to Mudassir. He will try to find out the Discord link and the Twitter or the YouTube channel.
So this is our Twitter, and all our previous sessions are recorded over here, and